Hi, everybody. It's 3:14. It's Karen Matzo, and we are going to start the webinar in about 2 minutes. I'm just going to wait for the last few people to get on, and then we'll start. Hello again, and we'll start our webinar now. This is Karen Matzo. Welcome to the Problem Solving and Data Analysis Across Disciplines webinar. We're happy to have you today. And I just want to draw your attention to the control panel on your right, because you'll be using that a little bit. First of all, at the very bottom, there is a chat mode, and feel free to use that. Above that, there are 2 of 5 handouts attached. One of them is a certificate of completion for an hour of professional development hours, and the other is just a graphic organizer that I have in the presentation that I thought you might like. We are going to be doing a poll later, and if you have questions, this is super important. As you have questions, please write them into the control panel, and I will monitor them, and I will ask them to the whole group and answer them as well, okay? If you could do me a favor right now, just so I can do a sound check, would you mind just typing into the question space whether you can hear me or not? If you can hear me, just write, I hear you. That would be terrific. Thank you. Okay, excellent. So welcome everybody. Again, I am Karen Matzo, and I will be delivering your webinar today. There is me. Hoping some of you on the webinar know me. I wanted to let you know that today's webinar is recorded, and so if you know of any of your colleagues that are missing the webinar, it will live indefinitely on our DS Professional Development Resources site. If you look at the bottom of this slide, it says webinars, and all of our webinars are listed underneath there. You click to open, and it'll say something like access the webinar here, and then it'll take you to a link in Vimeo where you can listen to the webinar. The handouts from today will also be available in that space, as well as any other resources that I come up with related to the webinar, okay? So today we're going to talk about problem solving and data analysis, and this webinar evolved through some of the work that I've done in high schools around the math SAT. And it evolved from this idea that problem solving and data analysis really is a cross-disciplinary skill. So I wanted to use this hour to connect teachers with some resources and some strategies for using data in the classroom, and some collaborative problem solving strategies as well. There is a math professor slash teacher named Joe Bowler from Stanford University that the math specialists on our team really respect a great deal, and they use a lot of her work in the younger grades. She just wrote an article about a week ago that was very relevant to this presentation. So I have a couple of quotes from that article here, and I have the name of the article at the bottom if you guys want to access it on your own. Every high school student should graduate with an understanding of data, spreadsheets, and the difference between correlation and causality. Moreover, teaching students to make data-based arguments will endow them with many of the same critical thinking skills they are learning today through algebraic proofs but also give them more practical skills for navigating our newly data-rich world. So I thought that that was sort of a perfect quote for the webinar today. Some of you may know me. I am, by trade, a literacy person who has gotten into this data world via demonstrated success and being a consultant to the Department of Ed for, I was a data consultant for, 10 years for the Department of Ed. So I have a new lease on data, but I also, I'm not a math teacher or a math specialist, so that when I view data, it's through the lens of language and problem solving and critical thinking. So I think that this quote from Joe Bowler really emphasizes that the use of data and spreadsheets, and it really is all about critical thinking and using language to interpret data and problems and make those interpretations and observations applicable in our everyday living, basically. And I have one more quote from that. Database courses allow students to grapple with real-life problems. And this webinar is going to be about, a lot of the webinar will be about using data in real-life problems in various disciplines. They might analyze issues about the environment, space, travel, or nutrition. Students can examine the threat of wildfires or the ways that social media is tracking their data, learning how to apply math to real-world issues. And really, it's more of the same. You will see in this webinar a lot of examples of using data in real-life situations. This particular article from Joe Bowler is about this potential shift from heading towards pre-calculus to having students instead take statistics as a more practical and usable skill than pre-calculus or than calculus might be for the majority of our students. So that really is the foundational question in this particular article. It's a very interesting article. And even I don't know as much about math education, I'm sure, as many of you on the webinar, and as certainly as our math specialists in demonstrated success. But it seems very reasonable to me that for many, many students, statistics might be more useful than calculus. So I just want to start off by talking a little bit about the mathematical shifts. I think that, and this I know from working in the field and working with our coaches here, that we are doing less and less problem solving to practice a skill. When I taught elementary school and when I was in school, it was very much you learn your skill and then you're introduced to a word problem, right, that would emphasize the skill that you just learned. And I think that we're moving away from that to sort of presenting problems as points of entry for a skill, right? And presenting problems that bring out math concepts for the students. So it's a more inquiry-based model in math than it ever has been before. And then also, it's not so much, a single correct answer, right, as it was when maybe we were younger, but it's more about presenting problems that have multiple answers and encouraging students to evaluate the solutions that they've come up with for appropriateness and reasonableness. And I just wanted to emphasize, it's funny, I'm realizing a lot of people don't know about the 8 mathematical practices, but here they are. And again, we have making sense of problems and persevering in solving them, right? I like modeling with mathematics, constructing viable arguments, look for and using structure, and but the ones that we're really looking at today is making sense of problems and persevering in solving them, and that is a process and a practice that transcends math, and I would posit that it moves into a lot of the different disciplines. And I'm going to talk about that now. So I was, in preparation for the webinar, I did some looking again at some of the standards in the different disciplines. And for the social studies standards, right, we have developing, this is dimension 1 in the C3 standards, which is not formally adopted by New Hampshire just yet, but I'm hoping they will be. Developing questions and planning inquiries, right? So that whole problem solving gestalt and practice is very much a part of the social studies curriculum, and gathering evidence and evaluating evidence and making claims based on evidence. So, and for the sake of this webinar, I want you to think about evidence as being statistical evidence, graphical evidence, information that's presented in a visual way. And just looking at the science practices from Next Gen, right, the 8 science practices, I sort of read it out, those that I thought were most relevant. Certainly asking questions is very relevant to this webinar, as you'll see later, and asking questions about data and about problems. I think that I would like to also read out developing and using models, most definitely. Sorry, I forgot that. And analyzing and interpreting data, which is obvious, mathematical and computational thinking, explanations, and then number 8, communicating. And so part of what I want to emphasize in the webinar is the overlap between these standards. And then the science, that NIST standards, right? Or ISTE rather, but it's NHISTE, NIST. Looking at these standards and seeing again those repeated themes of, if you look at 5B, right, students collect data or identify relevant data sets, use digital tools, analyze them, and represent data in various ways to facilitate problem solving and decision making. So there's that overlap again. So as I said, the webinar was sort of birthed after the work that I did, or that I have been doing with a few different schools around the SAT. So not only do we see the demand for this work in our standards, right? But we see them on the culminating test in 11th grade. This is the assessment that we use as our 11th grade state assessment. And it's also a really high stakes assessment for our students. So I feel sort of an ethical obligation to give them the best shot. And I do believe, and I say this, and next week I'll be doing a sort of a parallel webinar around content area, language and vocabulary across disciplines. And it's similar in that since these skills are so emphasized and so high stakes for our kids, I think in the real world, but also in their testing situation in 11th grade and for further graduation, and they're moving forward into colleges, that we are really obligated to develop these skills not only in the math classroom. So what I read out here was just showing you sort of the content in the problem solving and data analysis section in the SAT. Ratios, percentages, proportional reasoning, to solve problems in, again, there it is again, in real world situations, including science, social studies, and other contexts, right? So where the students are asked to describe relationships that are shown graphically and statistically, and then at the end it just talks about how the assessment is really evaluating whether students are quantitatively literate. And I love all of the language in this paragraph. It's not just college courses, but it's in everyday life. And it's funny, I think what compels me to deliver the webinar is that for so long I have felt quantitatively illiterate in my everyday life. And I think relative to many, I continue to be. So it takes more mental effort for me, to do the percentages, to do the statistical analysis, to analyze graphs. So it compels me even more to make teachers across all disciplines want to teach this to their students. This is just a list of the elements of the skills in the problem solving and data analysis section of the SAT. You can see here, sample data down at the bottom, sample data about a population, conditional probabilities, conditional frequencies, categorical data. It's a lot of understanding graphs and percentages, relationships, proportional relationships. But I really, there's a lot of different kinds of graphs on there that the kids are asked to use and to interpret. And I just wanted to let you know that 29% of the SAT is problem solving and data analysis. So that's, that's close to a third of that section. And then the other couple of things to emphasize is that, and I'm sure many of you on the webinar know this, and some of you may not, but they provide a cross score in the SAT from the math and the reading and writing section that relates to social studies. So all of the questions, and let's just talk about math for a second, all of the questions in the math section, right, that are pertain to social studies topics are grouped in their scores. They're scored together, and we get, the students get a score for that content focus, and the same with science. So all of the problems in the SAT are aligned to a math or a social studies content area. So again, that makes it even more important that we include these types of problems in our instruction. I wanted to give you some examples here. So this is just an example of a math problem solving and data analysis problem that was aligned to science. And you can see here it's a multiple choice question. And they're asking about the function, the model, which of the following functions best models the number of bacteria n times t after t hours. I'm going to give you a chance to answer one of them. Here's the next one. This is a science or a health item, right? So how many of the 9 people have an actual height that differs by more than 3 centimeters from the height predicted by the line of best fit? So I'm actually, it'd be fun right now to see if any of you can offer up the answer. I'll give you, I don't know, maybe 30 seconds, and then I'll tell you what the answer is. I'm counting down. Anybody? Oh, somebody wrote in 4, and yes, that is the correct answer. Congratulations. I got a couple people. Good for you. Okay. And here's another one, a sample social studies item from the SAT. According to the table, for which age group did the greatest percentage of people report that they had voted? I'll give you a chance. I'll give you about 10 more seconds. Okay, and the answer is 55 to 74-year-olds. So I see a couple of you got that right. Good job. Okay. And here's another one for an economics example. Okay, mean, median, all right? I'm going to keep going though. It's just which of the following could be the median and mean amount of time worked in hours for the 40 employees? All right, we can give it a shot. Why don't you guys give it a shot? Anybody want to give it a try? Oh, Anne's on the webinar, my math colleague. Anne, do you want to give it a try? All right, somebody got it. It's D. All right. So anyway, those are some examples of the SAT, and those are some reasons, right, why we should probably bring in problem solving and data analysis in disciplines other than math when we have the opportunity. So now I'm going to show you some resources that I have put together. And so this is a fabulous resource that I found, and I would love to see, of those of you that are here, if you have, can you write in and just tell me if you have used this resource before? If anybody has used this resource. So the New York Times every week has a, posts a graph from what that was published as part of another article, you know, a regular New York Times news article. And it's called What's Going On in This Graph. And they have the same thing for what's going on in this picture. And I think it's sort of fabulous. So I am going to show you, this is the graph. Okay, so let's look at this graph for a second. And so we can see it's about sports, right? What story does this graph about baseball, basketball, and football ticket sales tell? And I'm just going to let you look at the graph for a second. And then I'm going to take you to, I'm going to take you to the site so you can see what exactly this resource is about. And so we see the years across the bottom axis and up the vertical axis. I guess well, that's part of the question. So I'm going to take you to the site by clicking here. And this is actually today's graph, right? So what's going on in this graph? Today is October 30th, tomorrow's Halloween, much to my dismay. Oh, I'm so pleased. I'm seeing that a lot of people have never seen this site. So that's great. I feel like I'm giving you something you can use. This is the graph, and every on Wednesday, so there's a whole cycle. They publish the graph, and you can sign up for this. I signed up, and it's $1. I think $1 a month or something, or I don't know. It's some really not relevant amount of money, although for teachers maybe it becomes relevant after you do it several times. But you can get the graphs and everything. A lot of it is free without even signing up. But so they publish the graph on Friday. And then they open it up, and you can assign students to the process. And the students it's a collective process with everybody that has signed up for the site. And the kids go through a protocol of, you can see down here, right? So it says by Friday morning, November 1st, they are going to reveal the graph's free online link and additional background questions, and they're going to reveal students' comments, headlines, and stat nuggets. So if you look at this is the process that they take kids through, right? And I loved this, and I'm going to go back to it when we talk about strategies. What do you notice? And all the kids are asked to do is notice. That's it. And this, it's funny because this actually parallels the protocol that we use at Demonstrated Success when we look at data with teachers, right? So what do you notice? And does anyone want to make a noticing? Is anyone noticing anything? Why don't you just write in the question section? What are you noticing? So I see someone is noticing that Major League Baseball seems to have spiked in 1995 and then completely, or 1992, and then dipped radically down and then gone back up again. Let's see. I want to see your observations. Minor League Baseball has had a steady increase in sales, yes. And then I see people watching sports changes over time, yes, and yes. Okay, so those are some great examples of noticings, right? And you mean we would accept everything from those observations to, minor league baseball is done in purple. It's the idea here is that there's no bad noticings. Okay, that's what we want to encourage our kids in an open-ended way, to give them the confidence to make observations without fear of failure. I think that one thing, and they talked about this in the site, the person that started this project, kids and adults, right? They're intimidated by graphic depictions and they don't know where to start and they shut down. And they feel that if they don't have the right answer, right, they can't participate. So we really want to encourage them to engage. I'm just going to read this one more. Football has a steady increase in sales. Major League has increased ticket sales in 2007 for top sales. Okay. All right, so you guys have made some great noticings. And then the next step is wondering. Like, what do you wonder? Are you curious about, what are you curious about that comes from what you notice in this graph? So if you guys could take a second and just think about, what does this graph make you wonder? And I'm gonna wait until you write in a little bit. What does the graph make you wonder? So I'm not a sports watcher. So this graph makes me wonder what motivates people to sit and watch other people play sports because it seems like a lot. So I have a question here. What is the cost of each of the sport tickets? So that's a great question, right? How does that impact or affect sales, right? Is the team having a championship year? These are such good questions. Excellent. And I am sure that here's another one. I wonder if the dip in watching sales is related to the economic status in the country at the time. I wonder that too. What was happening? Hold on, here's another one. What was happening when ticket sales increased or decreased during specific years? Excellent, okay? And I would bet that your students would be very engaged in this content. And I'm sure that they would have very, very good and interesting wonderings as well. So what we've accomplished here is that so far, right, you're engaging in this graph, right? Your noticings, your wonderings. I have succeeded essentially in engaging you in analyzing this graph in a really low stakes way. And that's what I like about this strategy. Now, so the next step that they take kids through is to try to write, I think this is really fun, to try to write a catchy headline that captures the graph's main idea. So I'm going to challenge you to do that. I feel like your wonderings are much better than what I came up with, so I'm going to actually challenge you to come up with a catchy headline for the graph, since I'm so kind of sports adverse. What is a catchy headline? And just so you know, all of this is input in this site into a collaborative and collective location. And then on, when did they say? Friday morning, November 1st, during the reveal, right? The team at the New York Times goes live online and gives shout outs and highlights different students' comments and observations, and then they talk about the graph and the information. Please show graph on screen again. Oh, sorry. Here is the graph. Okay, here's one. Sports ticket sales show people are more engaged in sports than ever. Awesome. Okay, it's a good catchy headline. Thank you. Anybody else? All right, nice job, everybody. That was great. So that is the basic process of this site. And I wanted to, let me just make sure. Oh, here, I'm gonna, why the highs and lows? So I think that was a question. Thank you, Sarah. So just to show you, so on Wednesday, October 30th, the American Statistical Association facilitates a discussion. Okay, so they have a whole discussion around the graph today, actually, right? And then Friday, they have the reveal. And this happens every single week. So I'm going to show you some of the other topics and graphs. It's endless as I was exploring this site. So I'm going to keep going here. Here are, for example, some graphs to use in social studies, and they have what's going on in this graph from September, from last month. And it talks about the working age population and how that's shifted. Some of the graphs on this site, a lot of them actually, are amazingly interactive. So if they're comparing two time periods, you just roll your cursor over the image and it shows you, 2000, and then you roll it over and it shows you the results for 2018, and it's really cool and engaging. So anyway, and on the left, we have gerrymandering, right, which is a topic of interest, at least to me, and I'm hoping that it's a topic in your social studies classes, in your government classes. So these are just a couple of examples. I'm going to keep going. And we have some more, around science. There's a whole unit. There's about 20 graphs on here on this program. It's a whole series of graphs around climate change that you can use. So I wanted to show you these. This one talks about the rising global temperature, and here's another one about the oceans heating up. And here's one for health. There's, I thought that this one with e-cigarettes was very, very, very relevant for our students. And on the right-hand side, we have a graph around calorie intake and portions from from 1986 up to 2016, right? And I think there's also another one, there's a couple more around health and wellness. So there's really a lot. They've been doing this for 2 or 3 years, and there's a lot of different graphs to explore. And again, it's called What's Going On in This Graph from the New York Times. So here's another site that I found. The site is called, I feel like maybe somebody's asking a question. Let me go to the attendees and make sure. Oh, no, okay. So don't forget, just type your questions in. So this is a site called Data USA. It was excellent, and it's all about United States data, all different topics. And so I just clipped this one because I thought it was interesting. This is an area of interest of mine lately. ethnicity and racial sensitivity in the United States. So we can see here that the majority of our students are white, right? These are the students that are awarded college degrees. You can see in the bottom left corner, the majority of degrees awarded institutions in the United States were to white students in 2016. There were 3.73 times more white students than the next closest race, which Hispanic or Latino. So I just think that's an interesting statistic to look at. You can compare it to Black and African American students, Asian students, and so on and so forth. So this is just an example. Really, really excellent, excellent information in Data USA, and I would encourage you, and it's at a level that would be good for your students. Okay. Here's another site, the American Statistical Association. I'm gonna, what? Hold on, that's next. I'm gonna take you over here. I might go back and I'll show you Data USA as well. It's a toolkit for instructors for stats classes, and so you can just see the site here. There are different case studies that you can use to explore statistics in your classroom. We got some Al Gore, airline delays in New York, okay? And just to keep going, this is a terrific site. I wanted to show you this. I'm going to take you to the live site. Just make sure nobody has questions. And this is student guides and teacher guides to different types of graphical analysis and charts. So, which was, it's really good. I was relieved to see it because this is the kind of thing that I would need as a learner. So underneath each type of analysis, we can see here, for instance, for stem plots, it will show you some images, and it'll take you through what stem plots are and how you create them to help make sense of data sets. And it'll give you problem solving samples, and this one is about shoe measurements for soldiers. And so I just, read through this, the foot lengths of soldiers. And then I liked the way they talked here. When you see a bunch of unorganized numbers, it's hard to determine whether or not there are any important patterns. But if we organize these numbers into a stem plot, we can get a better sense of how widely foot size varied. So this is the thing. I know that students are supposed to be creating models to solve problems. I mean, not that I have spent a lot of time teaching students how to create models, but I do know that that is a goal. So as a literacy learner and as somebody for who math language is a second language, right? This is a relief to me because I can see here an example of how to take a data set, which can be overwhelming and confusing, and this is one option for a model that I can create to quickly make sense of a lot of data that has come my way. And I didn't know that before. So it was terrific. So I think that this is a great site. I'll just go back to it, the Annenberg Learner, and they have a lot of good resources. So I hope that helps you. And then we have the US and World Population Clock. I probably should start going a little faster because we're going to run out of time soon. And this is cool. It updates our population information globally, like every millisecond, and it just keeps going and going. And we see here, we have population by age and sex, and it's interactive and cool. And I think your students will like it. And I want to keep going. And one more, census at school, another one. This is actually a site where you can do census surveys in your school and then use the kids' data for data exploration. So I liked that a lot. All right, a couple more resources. So another thing that I would encourage is using students' own data. So I have here, this is a report from the SAT site. And this is the distribution of SAT scores. And you can see here it's fairly self-explanatory, right? The school is on the left, the country at large is on the right, and you can see the distribution. So in this particular school that I was looking at, the highest group scored, or the most students scored at the 1,000 to 1190 in the band, right? The next one is the district, so it's going to be the same. And you can see for the state, that same band was the most frequent bands that students scored in, but a little bit, you know, the discrepancy between the 800 to 990 and the next 1,000 to 1190 was a little bit less. So this school clearly did better than the state. And it's fun. It's fun to have kids, especially if they did better than their peers, right? It's fun to have them look at their own data set, and it's a way to engage them. And this is just another way to engage kids in their own data set. This data is from a school-wide survey. And these were some of the questions on the survey, right? My teachers helped me connect things. We are learning to important current events or issues happening in the real world. And then we can see that it's a rating scale. And, you know, you can give this data to kids and take them through a process of, you know, well, what are you noticing? What are you wondering? There's, and we're going to go there now, some of the teaching strategies to engage kids with this data. So here we are. All right. So this is the Notice and Wonder protocol. And I wanted to take you here. So I'm going to just click on that. NCTM, the National Council of Teachers of Mathematics, has this Noticing and Wondering protocol. And so it's here for you. It's what we just did, basically. I notice, I wonder. But what I like about it, if you go to the actual source, is it talks about the process of implementing it. And at the top, I just want you to notice that it talks about the obstacle, you know, how kids, they don't trust themselves to make use of their own thinking. They freeze up, okay? They miss key information. They don't understand. So these are all ways to get them to, all different ways to engage them. Let me, looking, I think there's a question here. Interactive graphs and I'm just stopping for a second, guys, to answer a question. Interactive graphs and charts that engage the student will draw more to doing statistics. This would have been much better. Oh yeah, I think so too. Okay, interactive graphs are more fun, basically. So this just takes you through the process, right? You're going to display the problem, a scenario, a graph, a prompt in front of the room. What do you notice? Let the students do their noticing. They can, you know, there's a lot, as teachers, we know there's a lot of different ways to do that. They can write it down and flash it off on a board. They can go up to the board and write it. They can work in groups and share it. There's 1,000 different ways. You know, thank the students, and I love this, acknowledge each student equally regardless of what you think the value of their noticing is, right? Again, we want to affirm the contribution of all students at that point. And then this I love, forget the question, right? So don't pose a question. Don't pose something that has to be answered yet. Leave it open-ended. And let them do the wonderings. And I really love that. And then we have think, pair, share. I'll let you go and explore this on your own. But again, it's the NCTM and the I Notice, I Wonder protocol. All right. So here's a couple other things, and if you have joined us from Pinkerton Academy, you know some of this. So I will not be insulted if this is not new and revolutionary for you. But if you are not at Pinkerton, this may be new for you. The question formulation technique is a really good technique to use with these graphs and models that need to be interpreted. And this is by no means a comprehensive lesson on the question formulation technique. If you Google the QFT, you will see that this is a very well-known, widely used, reliable, and simple strategy that comes at it from, oh, what are their names? I can't remember their names, and I just taught a 50-minute lesson on this a week ago, 4 times. Luz and I forgot his name. Anyway, they work in Harvard and they're super smart, and this is the sequence. So you provide a question focus, which for the sake of this webinar, right, could be one of the graphs that we were looking at earlier. And it is the student's job to produce questions. That's all they have to do. So it's a little bit like the wondering, right? Now, the rule is that they have to write down all of the questions and they work collaboratively. And after they produce the questions, we talk about open and closed questions. And we switch some open questions to closed questions to open questions, and then we prioritize questions. And then we have had full participation from our student groups, and they are now engaged with whatever the question focus was. So we've hooked them. And then we have all their questions, and we can do with those questions, whatever we or, the class decides, or the teacher decides. So those are the 7 steps. I'm just going to keep going here. These are the rules for the question formulation technique. Ask as many as you can. Don't judge. Don't discuss. The writer writes them down just as they were stated. And anything that comes out as a statement, you change into a question. And just to emphasize that this is really encouraging divergent thinking, and it's a very, very, very good and safe exercise for students. And I think it's revolutionary. I think so many of our kids go through their schooling looking for the right answer, looking to the teacher for the right answer. And for many of them, if they think they can't come up with the right answer, they become non-participatory. So I just really like this. I'm going to have you do the exercise, actually. So what questions? If you looked at this graph, and so if you look at this graph in the right-hand corner, the light blue shows you the usage of skill for reading. The dark blue is the skill usage for writing, and the yellow shows asking questions, the using of asking questions. And so the age of the student is on the bottom axis, and the percentage up the left hand, the vertical axis. So if you guys, can you brainstorm some questions that you have for this graph? I'm gonna give you about 15 seconds and then I'll jump in. What are some questions that you have? Here's one. Why do children ask less questions as they age? Yeah, I wonder that too. It's not just children, it's adults. Goes right up there. The stakes are higher as they age. It's a really good question. So theoretically, right, we would all be sitting, there'd be 100 of you out there, we would all be sitting in groups, you'd be writing questions like crazy about this graph. Does anybody have any more? That's really kind of the main question. I have the question of why does the questioning start to drop so early? That seems very early to me. And then my other question is, where does the graph continue to go down into adulthood? Those are my questions. Okay. After the group has brainstormed their questions, right, they take a closed-ended question and change it to an open-ended question. Then you experiment with that, and then the same for open-ended questions to closed-ended questions. And then you have a conversation. What are the advantages of open-ended questions versus closed-ended questions? This was a good, I'm sorry, I'm just going to go back for a second. Another question came in on the graph. How can we increase students asking questions? I think we can use some of the strategies that we're talking about on the webinar, I hope. So going back to the slide, the advantages and disadvantages, right? So when you ask a closed-ended question, you get immediate information, right? You can establish foundational knowledge that way that allows you to then pose more complex questions. So those are some sorry, we're talking about open-ended. I just answered for closed-ended. So the advantages of open-ended is that you can get detailed information, you can get more information, you can get information that you didn't even think of, right? It allows you to delve into a topic in much more depth. And then the disadvantages are, as you guys know, because you provide open-ended questions and assessments all the time, right? It takes longer to formulate an answer and to get information, and that can be hard. I'm just looking at the confidence, yeah. I just have a great question here. How can we help students answer their questions with confidence? Well, one way, and we'll talk about this in a little bit, I'm really into collaborative problem solving, so I will show you a strategy for that in a second. So then we talk about the advantages and disadvantages of closed-ended questions, and for the sake of time, I'm not going to go into detail right now, but if you want to talk more about the QFT, I am so happy to do that. Just send me an email. Then you're going to have kids prioritize questions. So what are their, and then we go to convergent thinking, where we start to evaluate what are our favorite questions, what are our most useful questions, what are the questions that we have here that are going to get us the most information or the most essential information, so they can narrow down and focus and choose together, 3 or 4 of their priority questions. And this is just repeats what I was saying earlier. What do you want answered? What are most important? And so on. And then you're going to share. So you're going to have a whole class share out. And you're going to list your priority questions. And you're going to justify your choice, right, for those questions. And then you can talk with the kids. How are we going to use our priority questions? You know, they may want you to answer the questions. You may be able to give out tasks to have students answer different questions. It motivates them to then do the work, maybe in their small groups. Maybe they want to switch questions and share questions and give questions to other groups. And then you can move on to reflections, right? We always want to reflect on the process and also on what we learned from our peers. So I am aware that I have 9 minutes, so I just want to make sure that I can get everything in before we go offline. So this is your reflection piece, and it's nice. You know, the other thing is, if you reflect on the process and what you learned from other people, you can also build interdependence in your classroom here, because then the kids acknowledge that they were helped by their peers and that they constructed knowledge together, and also on the process. Okay, the next thing I just want to share with you is reciprocal teaching. And again, if you've called in from Pinkerton, you know all about reciprocal teaching by now. So, if I forgot anything, you guys could write in. Again, this is not a comprehensive review of reciprocal teaching. I am so happy to talk with you more about this, but if you send me an email. But there are classic steps to reciprocal teaching, but when we do reciprocal teaching with problem solving, we modify the process. So with reciprocal teaching, kids are working in small groups of 4, let's say, and everybody sort of has a role or a role card. One of the roles is predictor, and that person is going to explore these questions. So the visual here, and I have a little video for you, is you have a group of kids sitting together. They all have a copy of a problem. They all have a graphic organizer that plans out for them these 4 steps with a place, and I'll show you the graphic organizer in a second, with a place to respond to each of the 4 steps. So the first step is looking at the problem and predicting, what do we think? What type of a mathematical question is this, right? Is this a statistical question? Is this an algebraic question? I don't want to talk too much and throw too much out there, because then you'll realize how bad my math is. But so they're going to ask, what type of a math question is it? What operations might we be required to use? And this is all a collaborative conversation with your students, with the students in the group. It's a student it's a student run. Well, you're facilitating it, but they're independent of you at this point. What do we think this problem is about, and how do we estimate, what do we estimate the answer to be? And they are going to take notes as they have this conversation. And then the next step is reading the question aloud and alone to clarify, what words are we unfamiliar with? What do we know for the problem-solving process? What is the information that we know here? And what is the information that we need to know that we don't know? Then the third step, we need to go about solving the problem together. What are our strategies and our plan to solve the problem? Can we use pictures, diagrams, numbers, words, graphs to solve the problem? And what prior knowledge do we have to draw on? Have we had a problem like this before? And then the fourth step is the summary and reflection. Students will solve the problem on their own. And this is their own summary and reflection piece. What did I use to solve the problem? Does the answer that I got make sense? Why is my answer the best answer? And then how does my answer compare with others in the group? And would I do anything differently given a similar problem? So those are sort of, now when you look for reciprocal teaching online with math, there's a lot, there's different modifications that people have made. And they're really, I just want to assure you, there's no right way to modify reciprocal teaching for math. It's basically what you find most user-friendly for your students. This particular process that I'm describing here with these modifications have been quite useful for a lot of the teachers that I've worked with. But if you don't find them useful, then you can modify in a different way. I'm going to show you this very quick video, just so you can get a feeling for what it would look like. Now, the prompts that this teacher is using are different from the prompts that I just went over. So I just want to reaffirm that it's okay to have different labels for your steps. Really, the emphasis is the collaborative problem-solving piece, the organization of it, structuring it for your kids, forcing them to have the conversations and record and go through the steps of the problem solving together so that they benefit from each other's expertise and each other's thinking. So this is just an example. Notice that they all have organizers and they have prompt cards.
These putting together alien toys called zergs and boards for the display window in the toy store. He has a box of alien toy body parts that contains 35 heads and 55 teeth. Each zerg must have 4 heads and 3 feet. Each board must have 4 heads and 2 feet. How many zergs and how many boards can we make if we must use all their heads including the box?
What information is important in this problem? So, the first one we show that the zergs must have 1 head and 3 feet.
What are we being asked to find in these questions? How many zergs and how many boards can he make if he must use all the heads and feet in the box?
Okay, so I'm going to go back to my slides. You get the drift, right? And you know what I'm going to do? I am going to upload this PowerPoint to our site so you can get it, and as well as getting the link. But what I want you to notice there is that they had definite roles, right? They passed the role cards around. They performed their roles, and they were in charge of those particular tasks for that group. They all had a graphic organizer. They were all accountable. One thing I would change is I would have multiple copies of the problem. Notice, just when you think about if you have any kids that are EL learners, how supportive this could be for them in their learning process. I really liked that. So I'm a big fan of that approach to problem solving. And attached to this webinar is this reciprocal teaching organizer, which mirrors the 4-step slides that I showed you earlier. So feel free to download that and use it. It's uploaded as a doc, so you can modify it, no problem. And I actually modified it from a beautiful teacher from Rumney. She had used a similar organizer. So we're gonna take a quick poll. You ready? We're at the end. We're right on time. I've never timed better. So here is a poll that I created for you guys. You ready? Here we go. It should come up. Is it coming up? Oh, launch poll. I believe that data literacy and problem solving is an essential cross-discipline skill. And you are going to vote, and I am going to watch the results in the polling window. Okay, the responses are coming in. Do, 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 do. All right. Guess what? Everybody said very much so. I'm so pleased. I'm glad. Thanks, guys. I've closed the poll. I'm really happy. I hope that the webinar was helpful. If you have any questions at all, or if you want to follow up in detail on anything that I've presented, definitely just send me an email. I'm happy to do a virtual meeting with you, and we can talk more. I can send you resources and stuff. All right, so here's my email. Karen.Mazzo. Uh-oh, there's a typo. It's not demonstrated success, it's demonstrated success. Sorry about the typo. So there's an O instead of an I. All right, take care. And I will stay on for a couple of minutes, or not, probably just about a minute, in case anybody has a question. And I can, if you want to put up your hand, I can unmute you. All right, take care, and thank you for coming to the webinar.